Dear students, welcome to EPG Pathshala. This module is an extension of the previous module, that is measure of dispersion 1. In this module, we will discuss relative measures of dispersion, that is an addition over the previous module. That is, in previous module we discussed absolute measure of dispersion, in which we derived the measure of dispersion in units. But in practical life, it is difficult to compare two data sets that is of two different units. So to overcome this problem, we have to find out the relative measures of dispersion. So here we discuss relative measure of dispersion in detail, and also we will discuss skewness and kurtosis. These are also very essential tools or measures for understanding the data set in a very depth manner. Hope you enjoyed this module, and let's get started. In this module, introduction to relative measure of dispersion and different measure of dispersion are discussed with examples. Properties of different measures are also discussed with merits and demerits. There are different relative measures like coefficient of range, coefficient of mean deviation, coefficient of variation, etc. Though this module one can easily understand about which method to use under what type of condition. In this module, another important measures like skewness and kurtosis are also discussed. As measure of dispersion is basically used to discuss about the variation, scatterness of the observations from the central tendency measure. We already covered the one category of measure of dispersion. In this module, the second branch of measure of dispersion, that is relative measure of dispersion, will be discussed. Relative measure of dispersion is a ratio of absolute dispersion with its appropriate average, that is to find out the relative measure of dispersion from an absolute measure. Then the quantity that is used in the denominator must be of same unit that of absolute measure. Mostly it is considered as the average. The basic purpose of using these measures over absolute measures that we can compare different data set, which is not possible with absolute measures due to its dependency on the units. Hence, the relative measure of dispersion have a great importance in statistics due to its property of independence of units. So the measure of standard tendency and measure of dispersion both together discuss about the characteristics of the data set, but they are not able to demonstrate that to what extent the observations deviate from the center value, that is whether equal number of observations are dispersed from the central tendency or whether the data is symmetrical about the mean or not. Therefore, it does not answer how many observations have their value below the mean value or above the mean value. If one is interested to know about the concentration of the observations around a central tendency measure, then it is essential to study two more measures. These are skewness and kurtosis. These two measures are considered as a supportive measure for better understanding the characteristics of the data. Also in the module central tendency measure 1 or central tendency measure 2 and measure of dispersion, we discuss about different central tendency measures and measure of dispersion. Skewness is basically used to tell about the shape of the data, that is data is symmetric or skew symmetric. Skewness value help in determining the concentration of the observations below and above the average value. If the observations are concentrated in the center, then it is called symmetric. If the observations lie on either side of concentration of observation, then there are two possibilities, either more than average value or less than average value. Hence, there are two types of skewness for symmetric data, that is positive or negative, depending on the concentration of the observations. We will discuss about it later. Another important measure is kurtosis, which refers to the peakness, flatness of the curve that can be drawn from the data set. It is basically used to study the concentration of the observations at the central point is whether more or less. If the concentration of observations at central part is very high, then the curve is leptokurtic. On the other hand, if the concentration of the observation at the center is less than the curve, then it is called platykurtic. Hence, central tendency measure Measure of dispersion, skewness and kurtosis represent a complete package to understand the data in depth. In other words, it completely describes the distribution of the data. So first, relative measure is given as coefficient of range. This measure of dispersion is evaluated from the range of the data set. First range of data set is calculated, and the formula for coefficient of range is capital H minus capital L divided by capital H plus L, where H is the highest value in the data set and capital L is the lowest value in the data set. Now, second measure of relative is coefficient of quartile deviation. This measure is defined as the ratio of quartile deviation to its average value. It is defined as coefficient of quartile deviation is equal to Q3 minus Q1 divided by Q3 plus Q1, where Q1 is the first quartile, Q3 is the third quartile, and we already discussed the definition of quartile in our previous module. So one can refer if it to the previous module if they have some confusion about the definition of quartiles. So we are here we have some data and we try to find out the coefficient of range and coefficient of quartile deviation. So first arrange the observation in an increasing order, then compute the range, which is coming up to be 55, and coefficient of range is evaluated as 55 divided by 129. So in percentage we will get 42.63, and now compute the first quartile and it is equal to 55. That is, first for that we have to find out the term that contains the values of first quartile. Similarly, third quartile, which is derived from the data, that is 12th term in the data set in ascending order, which is coming out to be 78, and the quartile deviation is derived from the value from the data set, that is 78 minus 53 divided by 2, and after solving it we will get the answer as 12.5. So coefficient of quartile deviation is coming out to be 19.08%. Hence, coefficient of range and coefficient of the quartile deviations are 42.63% and 19.08% respectively. So another measure of relative is coefficient of mean deviation. This relative measure of dispersion is derived from the mean deviation. Mean deviation is computed as the absolute value of difference of observations from the central tendency, that is mean, median and mode. Mostly mean median is calculated by taking deviation of observations from mean and median. So in order to convert the mean deviation measure into independent of units of mean deviation is computed as mean deviation divided by central tendency measure. Central tendency measure can be mean or median, but it is divided by the measure that is used for the deviation of mean deviation or from which the mean deviation is derived. For in the following data set we derive the coefficient of mean deviation, and we have this data set is of ungrouped frequency data. So from table 1 we can see that in the first column we have observation and correspondingly frequency is shown in the second column. So first compute the arithmetic mean of the data set using the formula summation over fi xi upon capital N, where n is equal to summation of fi. The values are shown in the table 2, and column 4 shows the difference of each observations from its mean value. Column 5 is the modulus of the value derived from column 4. Now compute this absolute value with the corresponding frequency. Compute the arithmetic mean of these absolute observation. Mean deviation of the observation is evaluated as 8.2278. To compute coefficient of mean deviation, first divide the mean deviation value with the mean, and the coefficient of mean deviation is given as 8.2278 divided by 50.65, which is, and the answer is coming out to be 16.24. So from table 2 we have in the first column we have observations, in the second column we have frequency, in the third column we have product of frequencies and observation, and in the fourth column we first derive the deviation from mean. For that we have to subtract the mean observation from individual observation, and after taking absolute of these observations, the values are shown in the column number 5. And if after product after multiplying frequencies with this fourth column, we will get the values in the column number 5, and taking summation the values is coming out to be 427.84, and now divide this sum with capital N, the answer is coming out to be 8.22. Now there is another measure of relative dispersion, and it is coefficient of standardization. As standardization is evaluated in terms of the observation unit and is considered as a absolute measure of dispersion, it is essential for the comparison purpose that the measure must be independent of units. The relative measure based on standardization that is independent of unit is called coefficient of standardization. It is defined as sigma upon x bar, where x bar is the mean of the observations. As coefficient of standardization would give in fraction, so if we want to express our coefficient value in term of percentage by multiplying the coefficient by 100, then the relative measure is called coefficient of variation, and the formula is given as sigma upon x bar into 100. The coefficient of variation is among the most popular relative measure of dispersion. It is basically used to compare the variability among two or more data set. The data set that has more values of coefficient of variation among two is said to be more variable, and vice versa. Now in this data set we have ungrouped frequency data. So we have observations in the first column and frequency in the second column. So first calculate the mean of the observations and subtract the mean from the observations, and values are shown in column number 4. Now takes care of these observations, and the values are shown in column number 5. Column 6 shows the product of frequencies with values from column 5. Now take sum of all the observations in column 5 and divide it by capital N, which is total frequency. So now after that take square root of the value, and the standardization value is coming out to be 11.190. So here we did same calculation that we have discussed here or discussed in the formula. So now for the coefficient of standardization, the formula is in the numerator we put the value of standardization and divided by the mean value, and the coefficient of standardization is coming out to be 0.22091. For the coefficient of variation we have to product this proportion with 100, and the answer is coming out to be 22.091. Hence we discussed about different relative measures of dispersion. As these measures are derived from the absolute measure to make them independent of units, so one should know about absolute measure of dispersion in depth and the properties before applying these measure on the data set. Now we will start a new topic, that is skewness and kurtosis. Basically skewness and kurtosis are the third and fourth order property of for understanding the data in depth. So first we will discuss what is skewness. A skewness is basically to see the tendency of the shape of the distribution. If the frequency distribution of the data is not equally distributed about the mean, that is the frequency distribution is not symmetric, then the term that is used to refer this situation is called skewness. Skewness has many synonyms like asymmetry, lack of symmetrical. Some other authors give definition of skewness as given below. When a series is not symmetrical, it is said to be symmetrical or skewed. This definition is given by Croxton and Cowden. Measure of skewness tells us the directions and the extent of skewness. In symmetrical distribution, the mean, median and mode are identical. The more the mean moves away from the mode, the larger the asymmetry of skewness. This definition is given by Simpson and Kafka. Hence, skewness means the data is not symmetrical about the mean. It is also be defined in terms of normal distribution. Normal distribution is the distribution which has mean, median and mode all are equal. Hence, the shape of the frequency of this distribution is like bell shape. So from this figure we can see that we have three curves. One is positive skewed, second is symmetrical, and third one is negative skewed. In the first figure, if we have positive skews, then the mode is less than median is less than mean, and if we have symmetrical distribution, then the mean should be is equal to median is equal to mode, and for negative skewed we have mean is less than median is less than mode. So hence from the figure 1, one can observe the shape of the frequency distribution. A frequency distribution is said to be positive skewed when the mean is greater than median is greater than mode. In this case, the value of mean is more than the value of median and mode. Also, median value is more than the value of mode. A frequency distribution is said to be symmetrical distribution when the mean is equal to mode and is equal to median. In this case, the value of mean, median and mode are same. A frequency distribution is said to be negatively skewed if mean is less than median is less than mode. In this case, the value of mode is more than the median and mean. Also, the median is more than the mean. Now, here we discuss the difference between skewness and measure of dispersion. As we discuss above, different measure of dispersion as dispersion measures are basically used to know about the variation in the data set, while skewness is concerned with the concentration of observation around the center part of the data. These are, skewness is basically concerned about the shape of the frequency distribution, while measure of dispersion are more concerned about the amount of variation. Skewness shows the nature of data about its center value, while dispersion try to measure up to what extent the central tendency value represents the whole data set. It is possible that a data that is not dispersed but has symmetric frequency distribution. Hence, in that case, one can say that symmetric data does not mean that variation is less. Measure of dispersion are based on first and second order movement, while skewness is based on first, second and third order movement. Now here we first give you measures for absolute measure of skewness. These measures of skewness are basically used to check the asymmetry of the data. Hence, these measures assume that the data is not symmetric, otherwise the values of these measures will be equal to 0. Some of the measures of skewness are given as mean minus mode, mean minus median, and third one is Q3 plus Q1 minus 2m, where Q3 represents the interquartile range, third quartile, Q1 is first quartile, minus 2m is 2 times median. Hence, by using the above three measures, one can check the skewness of the distribution, as we already discussed that in skewed distribution either the mean value is greater than median or mode is greater than median and mean. Hence, these measures just give you an indication about the presence of skewness in the data, except when the values of these measures is 0. In that case, data is symmetric. However, these measures of skewness have limited utilization in practice due to these reasons. These are, the first and the most important thing is that these measures are based on the units of the observation. Hence, the values that are derived from these measures cannot be used for comparison purpose. If absolute measure of skewness value of two datasets are same, it does not mean the datasets are always same, as it may be possible that there may be variation between distribution in terms of mean and dispersion. Now, to overcome these limitations, another measure that is independent from units is used, is called relative measure of skewness or coefficient of skewness. Now we will discuss some definitions of relative measure of skewness. In these measures, the limitation of absolute measures have been removed by dividing the absolute measure by the suitable measure or quantity. The following are some coefficient of skewness which are commonly used. First is Karl-Pearson coefficient of skewness. The formula for Karl-Pearson coefficient of skewness is mean minus mode divided by standard deviation, and it is also equal to 3 into mean minus median divided by standard deviation. The second relative measure of skewness is Bowley coefficient of skewness. The formula for Bowley coefficient of skewness is given as coefficient of skewness is equal to Q3 plus Q1 minus 2 times median divided by Q3 minus Q1, where Q3 and Q1 are the third and first quartile of the distribution. And the third formula for relative measure of skewness is Cayley's coefficient of skewness. Cayley coefficient of skewness. The formula for Cayley's coefficient of skewness is given as D9 plus D1 minus 2 median divided by D9 minus D1, where D9 and D1 are the ninth and first decile of the distribution. Measure of skewness based on moment. This measure of skewness is the most widely used method. Here the measure used second and third order movement about mean. This measure is defined as coefficient of skewness, which is equal to Q3 upon sigma power 3, where Q3 and sigma are the third order movement and standardization of the distribution. Here we are interested to find out absolute measure of skewness and coefficient of skewness by using the formula Karl-Pearson, Bowley, Cayley based on the movements of the marks of 15 students in statistics given below. So first we arrange the data set in ascending order. Now compute arithmetic mean, median and mode from the series, and the arithmetic mean is coming out to be 69.33, median is 69, mode is 63, and first quartile is 58, third is 85, D1 that is decile which is coming out to be 49, and D9 is the 9 decile and the value is coming out to be 90. Now for the absolute measure the values are 6.33 for the formula mean minus mode, and for the mean minus median the value is coming out to be 0.33. Q3 plus Q1 minus 2m is equal to 5. Hence all the absolute measures show the data is positive skewed because the value is coming out to positive. Now calculate the relative measure of skewness. We need standardization of the data. So for that we have to use the formula for standardization. So Karl-Pearson coefficient of skewness is 69.33 minus 63 divided by 14.079, where 14.079 is the standardization of the data, and the answer is coming out to be 0.4496. For Bowley coefficient of skewness, by putting the observation in the formula we will get 0.1851. So similarly for Cayley coefficient of skewness, after putting the values we will get the answer as 0.0243, and the coefficient of skewness based on movements. So here first we require the Q3 value and sigma power 3, and the answer is coming out to 0.0835. Hence from all the absolute and relative measure of skewness we conclude that data is positively skewed, although we also notice that different measures have different values for the same data set. That is considered as a limitation of the measure of skewness. Now here we will discuss the definition of kurtosis. Kurtosis word comes from the Greek language with a meaning curved arcing. Kurtosis is basically used to measure the peakness of the frequency distribution. It is possible that two datasets have same arithmetic mean, standardization and coefficient of skewness, but still one has different concentration of values near the mode value. So the distribution can have more peakness than the usual normal distribution, less peakness than the usual normal curve, and equal to normal distribution curve. So basically kurtosis is a measure that compare the peakness of the curve relative to the peakness of a normal curve. So kurtosis is basically used to measure the extent how the distribution is more peaked or less peaked than the normal distribution curve. Many authors give the definition of the kurtosis as a measure of kurtosis indicated the degree to which a curve of a frequency distribution is peaked or flat topped This definition is given by Croxton and Cowden. Kurtosis is a degree of peakness of a distribution usually taken relative to a normal distribution, and this definition is given by Speisel. From figure 2 we have three curves, and blue curve represent the leptokurtic, and black represent the mesokurtic, and red represent the platykurtic. So we will discuss what is leptokurtic, platykurtic and mesokurtic. So if the distribution curve is more peak than the normal distribution as shown with blue curve in figure 2, then the distribution is called leptokurtic. If the distribution curve is more flatter than the normal distribution curve, then the distribution is called platykurtic. Hence the black curve represent the normal curve is called mesokurtic. So there are some measures of kurtosis. First is defined as beta 2, which is equal to mu divided mu 4 and divided by sigma power 4, where mu 4 is the fourth order movement about mean, sigma is the standardization. If beta 2 is greater than 3, then the distribution is called leptokurtic. If beta 2 is equal to 3, then the distribution is called mesokurtic. If beta 2 is less than 3, then the distribution is called platykurtic. Another measure that is used in literature is given as gamma 2, which is equal to beta 2 minus 3. Hence in this case gamma 2 is greater than 0, then the distribution is leptokurtic. If gamma 2 is equal to 0, then the distribution is mesokurtic. If gamma 2 is less than 0, then the distribution is platykurtic. So we have a data set and we are interested in to find out the property of the distribution, whether it is leptokurtic, platykurtic and mesokurtic. For that we require the fourth order movement, and the formula for fourth order movement is summation of xi minus x bar power 4 divided by n, and the answer is coming out to be 71641.5407. and after putting the value in the formula for kurtosis, the value is coming out to be less than 3. And if we are using beta 2, if we require the value of gamma 2, the answer is coming out to be negative. Hence using the formula for kurtosis, we can say that the distribution is platykurtic. To summarize this module, as we already discussed different measures of dispersion, and the particular form is relative measure, and we also discussed that how relative measure is introduced, as we already have absolute measure of dispersion. So after that we also discussed skewness and kurtosis and its importance, how to derive skewness and kurtosis from the data sets. Hope you enjoyed this module. Thank you.